Alrighty, let's go ahead and use our TI graphing calculator in order to find a confidence interval where we do not know the population standard deviation. So now we are going to do the same thing we just did, but for a t-test, or I'm sorry, a t distribution instead of a z distribution. So again, we are back to our favorite button in stats class, the stat button. A confidence interval is still a sort of a kind of test, so arrow over into tests, except now we do not know the population standard deviation. We have a sample, and from that we calculated a sample standard deviation. When all we have is the sample standard deviation, we are now going to find a confidence interval using a t distribution. So t-interval. And if we look down here, all this list of things, we find that number 8 is our t-interval. So we can either type in number 8 or arrow down and enter. And again, we do not have our data in lists. We were given a problem in which we were told a sample mean, a sample standard deviation. We're not calculating it. This data button, this here is if we have all of the individual sample readings in our lists and we have the calculator calculate the sample mean and standard deviation and the sample size. We're not doing that, so we arrow over, we hit enter on stats to say switch to stats, and now we arrow down. For our problem, we are given a sample mean x bar of 37.1, either enter or arrow down to our sample standard deviation. Remember, we use the letter S for a sample standard deviation. For the population, it was that sigma, which looked like the little O with the toupee. We just used the letter S for a sample standard deviation of 12. And we go down to our sample size. We are told in the problem 150 subjects in the study. Our confidence level for this problem is a 90% confidence interval. So for a 90% confidence interval, our confidence level is 90 divided by 100, or 0.9. Make sure you check that. And enter to calculate, and there it is. Here is our confidence interval for a population mean when we only have a sample standard deviation, not a population standard deviation.